Hello and welcome to our next talk on day 4 at 1400. It's about Ruby on Rails security, do's and don'ts, and common pitfalls you can trap yourself into and shoot yourself into the foot. Please have fun and welcome Jonathan Weiss.
Yeah, thank you. Welcome to the talk Ruby on Rails security. Just a quick notion about who I am. I do a lot of Ruby on Rails work, consulting and code reviews, and also a lot of open source work in this area. So this is basically where my background is about. And we will look today basically at the whole Ruby on Rails application stack and follow it from setup and deployment of a Ruby on Rails application down to the framework code and look at information leaks, at possible vulnerabilities, what you can do wrong, what you can do right, basically to secure your Ruby on Rails application. So let's start basically at looking about how typically Rails applications are set up. So normally, basically you have a load balancer in the front that is then relaying all requests to dynamic application servers, and at the back end, of course, the database. And you have basically to do this in Rails because Rails is single-threaded. So you have to start basically a Rails process for each dynamic request that you want to basically handle concurrently. There are two common setups. We have basically the first setup that was used a couple of years ago, fast CGI. So basically you have an Apache or Lite web server in front of your application, and then you use fast CGI to communicate with your backend Rails process. The more common setup today is using Mongrel. So basically you have Apache 2.2 or Nginx or LiteHTTPD, and you're basically doing a pure HTTP proxying to your backend processes. And your backend processes have full qualified HTTP servers running Mongrel and Rails, but you still have like many Rails instances for each concurrent request that you want to handle. So yeah, this is just the background to know how Rails applications are typically set up, and then we will look where there could have been some problems in the setup. So let's begin with looking at typical information leaks and vulnerabilities that you can find in such setups. At first, if you target an application, you want to know, is it a Rails application or is it a PHP application or whatever? The first hint are the URLs. So basically, Rails by default gives you, for all your static files like /javascript, application.js, /javascript, prototype.js, or /images, and then all your images. So this is a hint that it is a Rails application, or the pretty URLs as they are called. So basically, you have very meaningful URLs in a typical Rails application. So you have like project show 12 or message create or folder delete 43 and so on. So just by looking at the URLs of the application, you can guess if it's a Rails application or not. But guessing is not enough. So we want to be sure. And one little trick that basically always works is looking at the status pages. So Rails provides default status pages for internal server errors and for the 404 page not found error. So basically, if you use a very common plugin and your application basically raises a 500 error or 404 error, Rails will display a default page to the user that says page not found or internal server error. And those pages are in the public directory of the Rails application. So they're basically publicly accessible by default. So you can not only tell if an application is a Rails application by trying to find those pages, but you can also tell which version of Rails it is. For example, in Rails 2, they introduced a 4.2.2 HTML page for the for access denied error. So if you, for example, ever wondered if Twitter is really a Rails application, just get twitter.com/500 HTML. And you get the error page that Twitter will show you if you ever really create an internal server error. Or if Strongspace is a Rails application, just strongspace.com/500.html, and you get the error page. 43 people, a different page. Basically, this is the default page for Rails pre 1.2. So we alone by looking at this page, we know that the application was was either not properly upgraded or is still running on pre-1.2 Rails code. Because after 1.2, the default error page would look like this. So basically, you can just try these URLs at the application that you want to target, and if you get a page like this, you know sometimes the explicit version of Rails, and basically is it really a Rails application or not. Another thing to look at is the server header. If you remember the setup, we had either fast CGI in front or Mongrel in the backend, basically. So for example, let's query 43people.com, and we get Apache 1.3 with mod fast CGI back. So we can nearly precisely say that this is basically running Apache in the front and fast CGI process at the backend. And this has different implications if you want to target this application. Let's look at high-rise from 37 signals, and then you get basically not the proxy in front like with fast CGI, but you get the backend Mongrel answering you. So you see Mongrel 1.1.1 answering you. And this is an important information because just 2 days ago there was a vulnerability found in Mongrel's version pre-1.2, 1.1.2. So basically we now know that they are running a vulnerable Mongrel version. So what can you do against it? Basically, disable the server header. Easy to do with Apache. I'm not sure how you do it with Lite or Nginx. Those are basically the most common Rails proxies or web servers that you put in front of your application. But by looking at the headers, just using a URL, you can pretty much say which version of Rails is the application running, is it using fast CGI or Mongrel, and how are the detailed setups. Another thing that is easy to find out is the subversion metadata. I would say that basically all Rails applications that are looked at are using subversion for source control management, very nice. But it's also basically the default setup to deploy those applications with Capistrano or Webistrano. Those are in the Rails with very popular deployment tools, where you can basically push new versions automatically on many servers. The only problem with it is that in the default configuration that basically 90% of the people are using, you will also push the .svn metadata folders to the server. So the nice thing that you can do then is just query them. So again, strong space, just look up .svn entries, and we get the content of the svn meta files. So we can now know that basically they're running some depreciated version of strong space. Maybe it's not maintained anymore. Maybe they're not developing it. You also see the last commit from which developer. Not really information that you want to put into the public space. How can you protect against it? Basically block in your proxy all .svn access attempts. Quite easy to do, but also about 99% of the applications out there are not doing this. So those were basically very simple means to query information about target applications. Now let's dig a bit deeper into how you can basically mess up your setup, or what you should know about a Rails setup. One thing that Rails 2.0 introduced is that by default now sessions are stored in a cookie on the client side. Typically before that you would have them on the file system or in memory or in memcached or something like that. Since 2.0 it's by default stored on the client side in a cookie. So you would get on the top basically the cryptic string that if you look into the cookie on your browser. And what the string is basically is just the pure session data encoded in base 64 and an HMAC that will ensure validity of the string, so that if you tamper with it, the server side will see it. But the problems with this kind of steps are that basically the user can view the session information in clear text. It's just base 64 encoded. Also because you have the hash on the client side, the client can run a brute force attack on it. And if it's successful, he basically can generate every session data that he wants. He can impersonate an administrator, he can mingle with the session and do basically very, very easily hack your application. Also, even if brute forcing the HMAC is not successful, you can replay attacks are much more easier. Because you have basically no means of invalidating the session on the client side by default, unless you do something about it. So basically, if you ever store important information like credits left or something like that in the session, a user can just replay this valid session and basically never run out of credits. So what you should do against it is basically don't store important information in the session. Should be common sense. Use a really strong password for the computation of the HMAC. By default, Rails since 2.0 forces at least 30 characters, and by default they are randomly generated, so it's pretty secure if you want so, but still a brute force attack is possible. So if you ever change this default password, use a very long and random one. And you should definitely introduce some kind of server-based session invalidation. So basically store when the last time was that the user logged in, and invalidate or block further attempts after a certain time, because you cannot guarantee that the client-side session will invalidate by itself, because a malicious user basically can just replay it. Or just switch to another session storage. Very easy to do, and you should do it if you have basically high security concerns. How does it look like? Basically just a sample output of the default hash, so the default password, so we can see it's pretty secure by default. So basically this long string is the default password that Rails will generate if you create a new Rails application. Another thing that you could do is just force HTTPS only cookies. Another common attack at web applications is cross-site scripting. So cross-site scripting is basically if you let your users input some values into your application and you're redisplaying this information on the web page or in your log files or in your administrator interface or whatever, they can do nasty things. Basically, they can steal your cookies, they can then impersonate administrators or do or fool other users. So what can you do against it in Rails? So basically there are two types of cases that you will have to worry about. You have the case where you basically don't ever want to have formatting in this user-submitted string, like in search queries, in usernames, and titles, whatever. And you have the case where you want some kind of formatting, like in a post body, in a wiki page, or where you basically explicitly allow some kind of formatting. So the first case is pretty easy to handle in Rails. You have the H helper, it's the short for HTML escape, and it will basically escape all dangerous HTML characters and force basically a plain text evaluation of the text. So basically you're pretty safe by default if you're using this H helper method. The only thing is that it's quite easy to forget to use it, because you have everywhere you want to use it, you have to explicitly put H around your outputs. So a nice plugin is SafeERB. It will basically making calling H the default. So if you ever forget it, it will raise an exception, and if you ever want to explicitly output possibly malicious input, basically you have to untaint the string so that the code will allow you to print it. So you should definitely use it if you want to be on the safe side. The other case, if you explicitly want to allow some kind of formatting, is a little bit different and a little bit harder to get right. There are basically two approaches. The first approach is, you introduce some kind of DSL. So you say, I don't let the user input HTML, I let the user for bulletin tags or red close syntax or the text style or whatever, and it will then convert it to HTML. And the other approach is to basically allow HTML, but have a filter that will filter out every unwanted stuff. And in Rails 1.2, you had a blacklist based sanitizing for that. Didn't work really good. And since Rails 2.0, you have a whitelist approach to it. So let's look at the first step to do it, or the first way, if you're using basically something like red close or text style, whatever. The problem with that is that it's not really secure, because their parsers are also not really perfect. And for example, red close, a very popular formatting library in Rails, is pretty much useless to filter HTML, because as you can see, I can just links are by default not filtered, even if I tell it explicitly to filter HTML tags. So cross-site scripting attacks is still possible. So basically, you have to filter this output anyhow. This basically just leaves you to the other case where you basically have to filter the HTML tags. Since Rails 2.0, it's quite easy to do it. You have the sanitize helper function that will construct a DOM out of this HTML input and will then filter nodes and attributes that are not allowed. But it's really only effective in Rails 2.0 because it's working with a whitelist approach and is basically doing all the hacks to convert ASCII and Unicode and hex encodings to basically clear text and then do the filtering. So if you're using a Rails 1.2 application, you should definitely upgrade or not use the sanitize helper. If you want to be really on the secure side, use tidy to basically pre-process the HTML. Tidy is a C library that will get every kind of mangled HTML code and construct a real nice XML syntax tree out of it. So if you really want to be on the safe side, run tidy over the input, then do sanitization. Another common attack is session fixation, where an attacker basically pre-handles you a link or where he basically defined the session identifier. So in typical PHP application, it's very easy to do because you have oftentimes the session identifier in the URL, like in this example. So if I paste you this string in an iMessenger, in a mail or whatever, and you click on it, we both share the session because I know the session identifier that identifies me to the server. So basically we share a session, and but therefore if you're an administrator or you have basically, this is your bank account or whatever, I have the same access that you do. And what can you do about it? If you only keep the session in the cookies, it's a bit more difficult to do this kind of attack, but it's still a viable attack. But at least Rails only uses cookie-based sessions. So it's not vulnerable to this very easy kind of attack where you basically just put the identifier in the URL. But still you should basically reset the session after each login. So what you're basically doing is, after the user authenticates, you reset the session, create a new session identifier. So even if the attacker knowed the session beforehand, the session identifier, it's no longer valid. Just easy to do, reset session, just call it in your login and logout functions. Very easy to implement. But the important thing to know, if you're using a popular authentication module like RESTful authentication or some other generators, they are not doing this. So basically, you are vulnerable to session fixation attacks if you're using the pure plugins. But it's easy to fix. Just insert the reset session and wait for the next version of RESTful authentication that will fix this. Another common attack and very, very dangerous one is cross-site request forgery. Got a lot of press recently because it's really, really sophisticated attack that can do a lot of damage. Basically, you visit an evil site that has nothing to do with your site, basically. And this site has an image tag somewhere or an iframe or whatever that will just reference a URL of your site. And if you have a valid cookie on your browser, your browser will go to this site, will try to fetch this image, go to mybank.example account transfer, and basically call this URL, issue a request, and because you have a valid cookie, this is a valid request. And if you're having, if you're allowing transferring money with such kinds of requests, you are in big trouble. Many people think that basically you can just switch to post, and because post cannot be injected like in images or iframes and so on, you're on the safe side, but that's not true. You can force client-side JavaScript request, and thereby basically only allowing post is a little bit more secure, but it's not really secure. It's just making it a bit harder for the attacker to craft this kinds of requests, but it's still easy to do. For example, Gmail had a vulnerability like this. So what can you do against it in Rails? Since Rails 2.0, by default, all actions are protected against such kinds of attacks. So basically, by default, Rails calls the helper protect from forgery and passes a secret key. And what this will do is it will, in every post request that requests either HTML or AJAX output, it will verify that the post request has a valid session token. So, and this session token will be put in each form that is generated by Rails and the Rails helpers. So basically, by doing this, you can verify that the request is really coming from somebody using your page, because otherwise he wouldn't have this secure token in his session and in the request body. So what Rails will then do is basically look up the token in the post and compare it with the token in the session and see if they match. By default, it's activated, so it's very, very good that they did this. You can also like customize it, only activate it on certain actions, certain controllers, and so on. But since 2.0, it's activated by default. And if you're not using it, you should, because attacks like I just showed you are very, very feasible and very, very easy to do. So the thing that you should make sure if you're using it is make sure that all your GET requests are safe and idempotent. So basically that you don't have requests like I showed before with the image. Because by default, Rails will not check GET requests for this forgery protection. It will only check POST requests. And also make sure that you invalidate a session token of a certain amount of time, because then all your users will get strange errors because Rails will think that they fiddled with the session if they don't invalidate like after a couple of days. But again, it's very easy to do, and Rails has this built in and activated by default. You should definitely use it. Another common attack at web applications is SQL injection. I guess everybody heard about it. So for example, I just want to do select star from users where username equals whatever input the user gave me, but he just gave me Peter, Mark, or 1 equals 1 and a comment. And basically broke my authentication if you want. So how can you basically do something wrong like this on Rails if you pass the parameters directly to the SQL condition? So this line on the bottom is vulnerable. What you should do instead is always use the escape form. Rails makes it very easy to do this. There are several methods to call it. So basically you can either use an array and question mark wherever you want the parameter and just list them at the end. So each question mark will match one parameter. You can also pass in a hash where basically you have the attribute that you want to filter on it and the value that should be user submitted or whatever. You can also do this with arrays. So it's very easy to say select all categories where category ID is in user submitted array or whatever. And you can even not use question mark, but use really like value identifiers. It's really easy or handy if you have like big, long filters and where clauses where it's kind of not easy to know, okay, was this value the first, the third question mark or the fourth or the fifth? So you can even use this kind of lookup, name lookup definition. If you ever have to use manually somewhere in your assembled queries a value that is user submitted, always use the quote method. The quote method will basically ensure that the value is properly quoted depending on the database that you are using. You can even pass it a second argument that would tell it which attribute this value is matching against. So basically, it will then quote integers differently than strings, because it will look up, oh, if you're trying to quote the username is a string, I will quote the string as a string. And in the second case, you're trying to quote the age is an integer, so I will try to quote it differently. And by using basically those helper method, you're always on the safe side with SQL injection in Rails. So it's not really easy basically to fall into this pit and ever using user submitted values directly in Ruby on Rails. Another very common, or not so common attack, but very nasty one that gained some publicity because Gmail was also vulnerable against it is JavaScript hijacking. What it basically means is that Ajax applications that output JSON value are basically vulnerable to data leaks. For example, you visit an evil page, and this page has a script tag that references some JSON action of your page. So for example, in this case, we are on evil.com, and evil.com has a script tag that references transaction.json. And transaction.json is a valid action on your controller that will output all your recent transactions in JSON. JSON is JavaScript object notation, so it's basically valid JavaScript objects. And what the JavaScript engine will do if it ever sees such a request, it will basically try to eval it. Normally you use JSON as a response format in your Ajax calls, and you will store this evaled response in a variable or in an object or whatever. People thought that because you're using the script tag, it's basically the browser evals it and then it goes away because it's never stored somewhere. But JavaScript is a very flexible language, so it allows you, like Ruby, to redefine built-in methods and objects. So what people started to do is then redefine, for example, the array object. And because this is an array, and what the JavaScript engine of your browser will then do, it tries to parse this response. So basically it calls the array constructor. And if you override the array constructor with a version that after constructing the object will just post it to another backend side, you can just steal all JSON information. So for example, in Gmail, it was possible to steal all your address book. In this case, it would be possible to steal all your past transactions. And because JSON is very, very popular in Rails as a data transport format, it's quite easy to get vulnerable to it. You basically just have to have a publicly known URL that outputs JSON like username, last messages, or last emails, or whatever. And if you give it back in JSON, an attacker basically can access this data. Of course, if you have a valid cookie. So if I just visit evil.com and I don't have a valid cookie for my good side, this doesn't work. But if I don't delete my cookies, this is working. What can you do against it, basically? First step, don't put anything important into JSON responses. Doesn't really work always, because JSON is a very nice format to exchanging data between your JavaScript frontend and the backend. Another thing is use unguessable URLs. Yeah, use an MD5 hash of the user ID plus a timestamp or whatever to get the last transactions and so on. It's security by obscurity, not really secure, but better than nothing. Or use a browser that doesn't allow the redefinition of built-in objects, like Firefox 3.0 beta. But if you don't control the browsers of your customers or your end users, basically you're out of luck. So in IE and so on, it's still possible to do this. Basically, the only solution against this problem, apart from not using JSON responses, is to don't give pure JSON responses. Prefix it with garbage. So basically, if the evil side is doing the script tag include, the JavaScript engine of the browser will throw an error, a syntax error, because it cannot, it's not valid JavaScript anymore. So the array redefinition trick doesn't work because you have a JavaScript error. In this case, I just prefix it with high syntax error, and by doing this, the script tag attack doesn't work. What you then, as a valid user of this JSON response, have to do, basically, you have to filter this prefix before you access it. You can do this because you don't, because your JavaScript is executing in the same context as the original site, so the cross-domain restrictions doesn't catch you here. So basically, you don't just eval the response, but you remove the first, in this case, like 10 characters, and then you eval the response. The problem is that the current Rails helpers are not fit to do this. So basically, you have to do all this by yourself. You cannot use the included Rails helpers that said, periodically execute something or do an update request and so on. This doesn't work. You have basically to manually write your own JavaScript library on top of prototype or whatever library you're using in order to use this kind of trick. I think that DWR, a Java Ajax library, is doing this by default. I think there is also a patch in the Rails track to attack this kinds of problems, but Rails 2.0 is basically vulnerable to those kinds of attacks. So if you want to really protect from them, you have to prefix all JSON responses with garbage and then filter this on the client side.
What about check the referrer?
Referrers can be forged very easily.
From within the browser, from the client side?
Yeah, you can, basically the evil side can have JavaScript that will tittle with the referrer, and then if you're doing the request, the referrer is changed. So
So it won't work with script tags, but it will also work with XML HTTP request.
No, forging a referrer will also work with HTML HTTP request, but the attacker cannot use HTML HTTP request.
So I just thought, if the attack uses a script tag, obviously you can't forge your referrer.
No, you could forge it in beforehand, before basically putting the script tag in it. There are different kinds of hacks to do this. Even I think if the client is using IE, this page could have an ActiveX object loaded before the script tag that will change the referrer and so on. So
Okay, I see.
relying on the referrer is basically a better step than doing nothing, but it's not really secure. Basically, there are ways around it. The same thing is you could check basically the IP address, match that you have like a call to the page before a call to the JSON. That will have matching IP addresses and so on, but referrers, IP address and so on can be forged, and also you have problems if somebody is behind a proxy where his IP address is changing, you would break this kind of operation. So basically, the only real solution is either don't use JSON or don't put important stuff in it, or prefix it with garbage so that the script attack doesn't really work. And the reason why the attacker, just to show it to you, the reason why the attacker is not cannot do the filtering of the prefix beforehand is because the attacker can only include it through a script tag, basically. There are some other tricks that work in IE and so on with iframes, but the attacker cannot do an XHR request or an XML HTTP request because of the cross-site blockage, basically. So all browsers don't allow to do JavaScript, to have JavaScript doing calls to other pages if you don't have scripts from those pages in your so basically, if the page is not from the same domain. So this is why the attacker can only attack you through the script inclusion.
I have a question. You
Yeah.
mentioned that you could use secrets to protect post requests. Doesn't the same apply to the GET requests of?
Basically, yeah, you can do similar thing here. So it's very similar to cross-site request forgery. You can always force to have a valid session identifier before accessing this data. Then let's look at something that is Rails specific, mass assignment. In Rails, typically, you always, or by default, you're doing mass assignment. Let's look at, for example, at a user. You have basically a user object in your application. It has a login, first name, last name, password, and the important thing, an admin field that is either one or nil, depending on if it's an administrator or not. And if you're using the code or the user object like this, basically, like it's generated by default through Rails. If you're just taking all the parameters that the user has submitted to you and update the user and then save it, what an attacker could do, it could just submit an attribute admin equals 1. Because the update attributes call basically will just take all attributes that are in this request, update the user, and save it to the database. So basically, a user could just upgrade to admin by doing this kind of request. And it's quite easy to fall into this habit because Rails is by default generating code like this and objects and model definitions like this. And what you have to do against it is basically tell your model that some kind of attributes cannot be set through mass assignment. The first way to do this is using attribute protected. So this macro will basically say the admin field cannot be set through mass assignment. Mass assignment means this where the code reads update attributes of params of user. Params of user is here a hash of all attributes that the user posted. So this will protect against it, and Rails 2.0 it will raise an exception, and Rails 1.2 it will basically just ignore the values. And the even better approach to do this is to basically not list the forbidden attribute, but list all the allowed attributes using attribute accessible, because by this way, you're on the secure side if you ever add new attributes. You don't, basically, if you forget to add them to this list, they're not vulnerable, but they're protected by default. This is basically a problem that you see oftentimes in code. So every important attribute, like foreign keys, for example, if I'm reading a message or I'm reading like a document in a content management system that is not tied to myself, so that I normally couldn't edit it, but I can just edit, for example, the title, but it's not owned by me. What I could do, it could update it and change the foreign key, because by default the foreign keys are also just attributes, and point it to myself, and voila, it's my document. I can delete it. I can do whatever I want with it. So you should basically protect all attributes that are not explicitly user settable, all foreign keys, all like admin equals 1, account paid, last time account exit, and so on. So all those attributes should not be settable through mass assignment. The next thing that is also very popular but kind of problematic are Rails plugins. Plugins are very popular in Rails space because it's very easy to add functionality to your code, just include them and it's working. But the problem with it is that people often forget that just because a plugin is out there doesn't mean that it's secure, it's proven, it's stable, it's mature, and so on. So even very popular plugins like RESTful authentication, maybe the most popular authentication plugin, are vulnerable. For example, RESTful authentication just had a vulnerability, I think 3 or 4 weeks ago, where basically every user who accessed the activation URL could impersonate the first user in the database, and this is typically the administrator. Another problem is if you're using a lot of plugins, it's kind of comfortable to not basically just get the code and put it in your subversion repository, but to use SVN externals. SVN externals are a mean of telling your source control system, here is a folder that is in reality sitting on another subversion repository somewhere in the net. And the problem with this is if the other side ever comes unresponsive or not available for like even a limited amount of time, if you're using the default Rails deployment method, you cannot redeploy your code because the subversion checkout will always fail because the external is not there. So what you should do against it is basically always do a code review, even if it's a brief review of new plugins that you're using. Track plugin announcements, so don't just get a plugin out of the wiki and take it, use it, and forget about it, but subscribe to the page of the author, look for security announcement and so on. And if you're using external sources, external libraries, plugins, don't use SVN externals, use either really copy the whole source in it or use Piston. Piston is basically a wrapper around SVN externals. So what it will do is basically you tell it, I want to mirror this remote repository, and it will note, okay, you're mirroring this remote repository. It will then do an export of this repository, so you basically have the code locally, but you'll still be able, because it knows where this code was coming from, you will still be able to do an update. So if you're using any kind of external sources, you should definitely check out Piston. Basically, yeah, the last kind of denial of service attacks against, or the last kind of attacks that I will talk about here are denial of service attacks. So as I said in the beginning, Rails is single-threaded. So typically, if you remember the architecture, we had the proxy at the front and then some Rails instances. And this number, typically you have very low number of instances to handle the load. So normally you have like 8 mongrels per CPU, and even quite active or large sites that are having like 500,000 page impressions per day are only using 10 to 20 CPUs. So you have like 80 to 160 active Rails processes. And by default in many setups, all traffic is handled by Rails. So this is a common Apache configuration for a Rails site. So basically you define a proxy with multiple backends in Apache, and you just tell it all the traffic going to root is redirected to the proxy. And if you do stuff like this, it's very, very easy to start a denial of service attack on your site if you have, for example, downloads or uploads or so on. If your site ever handles downloads or uploads through Rails, I just have to start X concurrent requests over a throttled line. So if you have like 80 mongrel processes running, I just have to start 80 uploads, and your page is dead, because there are no Rails processes left to handle incoming traffic. And this is also valid for all kinds of slow requests like image processing. If I upload a picture to your site and you're doing like cropping and resizing and so on, so it takes like a couple of seconds, and I upload like a very big image, and I do it concurrent times, I basically denied of service, basically your site is out of service. Or if you're doing like a report generation, where a page where a user can basically generate statistics of his profile access over the last couple of months or so. And this is taking like 20 seconds. You just have to call this page 80 times and your site is dead. Mass mailing is also a very common problem of this, or just normal down and uploads. And what you could do against it basically is always serve all static files through a web server, because they are much, much faster doing this. So it's very easy to do this through Apache and Lighty and Nginx, also for private data. So basically for data that nobody should be able to access, only an authenticated user. You can use xsend file for this, or even use Amazon S3 for public and private files. So basically you don't block on downloads. And but this doesn't help against basically the problem of blocking with uploads, image processing, and so on. And what you can do is basically contaminate slow requests. So instead of defining only one cluster for your whole application, you define several clusters for each specific task. So you have a cluster that handles normal traffic, you have a cluster that handles uploads, and you have a cluster that handles image manipulation or whatever. And you redirect to those clusters depending on the URL. So if somebody's attacking basically your upload cluster is starting like 20 very, very slow uploads of a 10 megabyte file. The rest of the page is working. So basically he denied of service your upload functionality, but the rest of the site is still working because only this cluster is basically hard working and responding to those requests. The others are still working. So basically you can contaminate slow requests. You can say if the image processing takes up too much memory, for example, this is also a common problem in Rails. Most people use image magic for image manipulation, and they do this inline, so basically in the same request that handles the upload, you do the processing. And the result of this is that you can have Rails processes with like 1 or 2 gigs of RAM because they're running so high processing those images, and image magic has not the best record of keeping memory footprint low and not having memory leaks. So by doing this kind of separation, you can basically ensure that only this cluster will ever grow in memory. The others are only handling normal requests and will not ever use or ever call the image magic code. So by this way, you basically, can just separate the functionalities, separate tasks, and thereby ensuring that the rest of the site is working, even if one part of the site is not responding. So basically, this was a brief overview. Let's look at the conclusion. In general, Rails had very, very good support for all kinds of security preventions for all kinds of attacks that we talked about. It has very good support against SQL injection. It's a very good HTML sanitization since version 2. Since version 2, by default, your site is basically cross-site request forgery protected. The problem is that all those things are very complicated. It's very difficult to get the setup right. Also, the Rails setup is not so straightforward like compared with a PHP setup or a J2E setup. We just have the application server. I just dump my WAR file on it and I'm done. I don't have to handle how many requests do I want to start up, to monitor all those processes on different machines. So the setup can be a little bit more tricky to get right, but still it's a very, very, very secure by default framework. So there are a lot of means that help you against attacks, and basically you should leverage all of those. So this was it. Any questions?
Okay, so I can talk very well. I have gold. Basically, I think there's a nicer way of protecting Rails against cross-site scripting. It was in Line Things Talks 2 days ago. The XSS shield, which basically means that you don't have to manually escape anymore. Everything will be escaped unless it's coming from a whitelisted helper, something like that. So in the future, that might be something you want to look at.
Okay, thanks. Another question?
Maybe let me add that this JSON vulnerability can be avoided by just adding JavaScript comment signs. And so you don't have to add crap, so you can easily add and put this JSON literal into comments, and then the eval would not work. But the script inclusion does not work. It's a comment, and then you can just add the normal script string manipulation to remove them and then eval it.
If it's working, it's great news because then you can basically reuse all the Rails helpers and so on. Yeah. Okay, so thank you very much.